In this video here, we're going to look at adding and subtracting algebraic fractions. Just like when you're working with numerical fractions, you can only add or subtract algebraic fractions when you've got a denominator that matches. So here, the thing that makes this first question difficult is not the fact we're working with algebra, it's the fact that the 8 and 12 are not the same. I need to rewrite my fraction so they have a common denominator. 8 and 12 are both factors of 24. So I can rewrite both of these fractions with 24 on the denominator. I can do that by multiplying the first one by 3 on the top and bottom, and by doubling the top and bottom of the second one. This will give me, for my first fraction, 21h over 24, and for the second one, 10h over 24. Because my two fractions have got the same denominator, I know my answer is going to be out of 24. I've got 21h's, subtract 10h's, will leave me with 11h's. Expressed as a single fraction. Now, it's always worth checking if anything will simplify here. The h obviously isn't going to simplify, as there are no letters on the bottom, but 11 and 24 won't simplify, as they don't have any common factors. The next one introduces some algebra to the denominators, so I've got a 5 on the bottom and an x on the bottom. So what I could do is I could try and change both of these so that I've got 5x on the bottom. To do that, well, I'm having to multiply this by x, so it means I've got to multiply the top of the first one by x, and here I've had to multiply the x by 5. So I have to do the same to the top. This will give me, on the top of the first one, I'm going to have an x times an x, will give me an x squared times y, and the second one, 1 times 5, is just 5. This means I can write it as a single fraction, because we've got the same denominator. I'm going to have x squared y plus 5. X squared y plus 5. Now, in the first one, I could write this as a single term, because these were like terms. I had 21h's minus 10h's. But the second one here, the x squared y and the number 5 are not like, they're unlike terms. So I've got to leave that as two separate terms in the end. Last question. This is a lot like the first question actually. I didn't, in the first question, just multiply 8 and 12 together to get my denominator. I found the lowest common denominator. So here, with this one, rather than just multiplying the two together, I'm just looking at them carefully. The 4 and the 2 can be made like by doubling the second. That'll give me a 4 on both of my denominators. The b and the b squared can be made like by multiplying the second one by b. So that will give me a 4b squared on the bottom of each of them. By keeping the common denominator as small as possible, it's going to save me from having to do any simplifying later on. So it means I can keep my first fraction the same and multiply the top and bottom of the second one by 2b. So this means I'm going to have 3 minus 1 lot of 2b. I've got a common denominator here of 4b squared. So I write that on the bottom, and on the tops and the numerators I've got two unlike terms, so 3 and 2b. So I've got 3 minus 2b. And I've got that expressed as a single fraction. These ones here are where it gets slightly messier. I'm going to change how I set this out. The problems creep in when we look at the fact we are taking away this expression here. So this is not just a single factor. I've got this x minus 8. So we've got this idea of we're having to take away negatives. So what I am going to do to help me whenever I've got a fraction that's got an expression like this, something that I could really write in brackets, is I'm going to write it as a single fraction to begin with and then look at doing my multiplying. So what I mean by that is this. I'm looking at my numerators. I've got 4 and 3. So this means I should be aiming to make my denominator 12. Here's my first main difference. I'm going to write this as one big fraction all over 12. And I'm going to consider what I need to do to each of the individual fractions to get that 12 on the bottom. Well, this first one, the denominator needs to get multiplied by 3. So it means the top will need to get multiplied by 3 as well. All of the top will get multiplied by 3. So I've got those brackets in there to emphasise it's all of that expression. And the second one, I need to multiply the 3 by 4. So the top needs to get multiplied by 4. Again, using brackets to emphasise the fact that it is all of that expression that gets multiplied by 4. Now, I'm going to rewrite this as a single fraction without doing any of the multiplying. I'm going to have 3 lots of this minus 4 lots of that. The reason I've done that is what will often happen is folks will multiply this out to 4x minus 32 and just write it down there without really worrying about that negative symbol too much. What I would do is write it out as a single fraction and then start multiplying out. So multiplying out the first bracket will give me 3x minus 9. The second bracket is being multiplied by negative 4 here because I'm subtracting 4 lots of this thing. So I have got minus 4x and minus 4 lots of minus 8. So that will give me positive 32. All of that is going to be over 12. Now I'm going to tidy up all of that that's on the top. I've got a 32 minus 9, so that will give me 23. I've got 3 x's, subtract 4 x's, will give me a negative x. All of that over 12. So when I was multiplying fractions and dividing fractions, I didn't bother multiplying out any brackets. However, here I have to multiply out these brackets because I need to group the like terms together. So this first bit has got some x's and some numbers. This bit here has got some x's and some numbers as well. For this to be simplified, the x's and the numbers need to be grouped together. The second one looks like it should be more difficult because we've got the expression bits on the bottom, but it isn't really. We need to write this as a single fraction. It needs to involve an x minus 5 and an x minus 4. So basically, we need a factor of this on the bottom, and we need that second factor on the bottom. And the way we would get that is by multiplying the first fraction, top and bottom, by x minus 4. So I've got 2 lots of x minus 4. And by multiplying the second fraction by x minus 5 on the top and bottom. I can rewrite this as a single fraction. We've got the same denominator. We don't need to worry that these are in different orders. The order we multiply things in doesn't matter. So these are the same. On the top, I have got 2 lots of x minus 4 plus 2 lots of x minus 5. I can go ahead and multiply these out. 2 lots of x minus 8 plus 2 lots of x minus 10. All of that will be over x minus 5, x minus 4. There is no need to multiply this out here. So again, I've multiplied out the tops because there will be some x's from this bracket. We'll tidy up with x's from this completely separate bracket. Here, this is all just one thing. There's no need to multiply it out because there's nothing else on the bottom to tidy it up with. Tidying up the top, I've got 2x plus 2x to give me 4x. Negative 8, negative 10 gives me negative 18. All over x minus 5, x minus 4. The top and bottom won't simplify. However, just to be sure, what I'm going to do is this. I'm going to factorise the top. So there's a common factor of 2 there, which will leave me with 2x minus 9. And I've got my x minus 5, x minus 4 on the bottom. Now, just checking, this factor doesn't match with any on the bottom, so it will not cancel out. But it's always a good idea, if you've got something like this on the top, to factorise it just to see if it cancels out with any of the factors on the bottom. In this case, we were lucky. It didn't. Right, one final one. Again, it looks intimidating, but it's not. All we've got to do is consider what our common denominator is. So this is all going to be over. I need a factor of x plus 1 on the bottom, and I need a factor of x plus 4. So I will get that by taking the first fraction and multiplying the top and bottom by x plus 4. I'll take the second one and multiply the top and bottom by x plus 1. So a lot of brackets there, but they're needed. So I've got x times x plus 4, subtract x minus 2, x plus 1. And that is going to equal. Now, the first bit of multiplication, that's nice and straightforward. I don't really need to worry about whether I'm adding or taking away here. However, here, I'm going to have to take away all of this. Because it's a take away, I'm going to introduce some brackets. I'm going to multiply out those two brackets in a grid, x minus 2, x plus 1. So again, I'm not writing all of this out, doing all my little steps for the multiplying out. It's taking a little bit of space over at the side. So I'm using a grid, but you could be using breaking brackets or whatever method works for you. So I know all of this is going to multiply to give me an x squared, negative x, take away 2. And all of that will be over x plus 1, x plus 4. That is going to give me x squared plus 4x. Now remember, this minus in front of a bracket really means I'm multiplying by negative 1. So I've got minus x squared, positive x, positive 2. And all of that is over x plus 1, x plus 4. Tidying up, x squared minus x squared will leave me with no x squareds. 5x plus 2. All over x plus 1, x plus 4. The top will not factorise, so there's nothing to cancel out on the bottom there. So I've expressed as a single fraction, and there will be no simplifying. So, for these, you need to remember, first of all, a common denominator. denominator. You need to write as a single fraction before you multiply out any brackets. So write as a single fraction before expanding brackets. This is because we need to take care when subtracting. Okay, so take care when subtracting. If you do that, you'll avoid potential errors and you'll be a lot more successful with this.